Let me do one more tutorial for second order non-homogeneous differential equation. Example: y double prime minus 5 times y prime plus 6 times y equals to x square. Solution: when I compare it with the standard form of second order non-homogeneous differential equation, these are maximum derivative terms. 5 is p of x, 6 is q of x, and x squared is g of x. How we know that it is second order non-homogeneous differential equation? When I look to the left side, the maximum derivative term is second derivative term, y double prime. It is a function of x, g of x. That's why it is called second order non-homogeneous differential equation. Step 1. To write the above function into differential operator form, which is d squared minus 5d plus 6 equals to 0. How we did that? Y double prime is actually d square or dx square equals to d square, and y prime equals to d or dx equals to d. That's how we can put differential operator. Step 2. To find the roots. There are two ways to find the root. One is to simply factorize the equation whatever we get in step 1. But in some cases, simply factorization is not possible, and then we use quadratic formula. Let me check here. The equation in step 1, d squared minus 5d plus 6 equals to 0, is able to be factorized simply. Just do factorization process. And now I have d1 equals to 3 and d2 equals to 2. Step 3. Let me show you some particular rules here. Rule number 1. If the root is real and d sub 1 is not equal to d sub 2, use this equation. Rule number 2. If the root is real and d sub 1 is equal to d sub 2, then use this equation. Rule number 3. If the root is complex, then you're gonna use this equation. But look at here. My d sub 1 is not equal to d sub 2. So I'm going to pick this equation, y equals to c sub 1 times e to the d sub 1x plus c sub 2 times e to the d sub 2x. Substitute the value of d sub 1 and d sub 2 here. The value of d sub 1 is 3 and d sub 2 is 2. This is the final answer for step 3. If the equation is second order, then differentiate y sub p, which is characteristic equation, 2 times. But first thing comes first. Let me check first the right side. My g of x is x squared, which is degree 2. So I will pick this equation, y sub p equals to x squared plus bx plus c. Y sub p is a characteristic equation. The next thing is to check the left side. The maximum derivative term here is second derivative, and therefore I'm going to differentiate this equation 2 times. Differentiate y sub p to have y sub p prime equals to 2ax plus b. And now differentiate y sub p prime, which equals to y sub p double prime equals to 2a. Now I will substitute these values for the left side. Replace this y double prime by 2a and y prime by 2ax plus b. Y by ax squared plus bx plus c. Simplify this equation further, and I have now 6ax squared plus 6b minus 10a into x plus 2a minus 5b plus 6c equals to x squared. Compare the left side with the right side. When I compare 6ax squared with the x squared at the right side, both terms have x squared. X squared at the left side has constant 6a, and x squared at the right side has constant 1, but normally we don't mention 1. So since both terms have x variables at both sides, and therefore x squared will cancel with x squared, and I have 6a equals to 1. This implies that a equals to 1 over 6. Now compare the x term with the left side. At the right side I don't have any x terms, I have only x squared. So 6b minus 10a equals to 0, because there is no x term at the right side, which implies that b equals to 5 or 18. This is a and this is b. Now look to this expression here, 2a minus 5b plus 6c. It's a pure constant expression. At the right side I don't have any constant. Therefore 2a minus 5b plus 6c equals to 0. Substitute the value of a and b in this equation to have c equals to 31 over 3. These are the values of a, b, and c. Now substitute the value of a, b, and c in y sub p equals to x squared plus bx plus c. Remember, this y sub p is a characteristic equation that has been taken because of the g of x at right side, which was a quadratic polynomial with degree 2. Just substitute the values of a, b, and c we just derived. So the value of a was 1 over 6 and the value of b is 5 over 18. The value of c is 31 over 3. This is the final value for the particular solution y sub p. Now step 5. To find the general solution. For the general solution, add y sub c and y sub p. Y sub c was c sub 1 times e to the 3x plus c sub 2 times e to the 2x. Substitute the exact value that was derived in step 3. And obviously y sub p equals to 1 over 6x squared plus 5 over 18x plus 31 over 3. Here is the final answer.